Hi there. Welcome to part 18, Wolves on the BackBit. Now, I'm Canadian, so this expression isn't really native to my country, but a dog's breakfast. Now, as you might expect, a dog's breakfast is something fit for a dog. It could be something burnt, it could be a whole mess of things, perhaps a little of everything in your kitchen, if you let the dog make his own breakfast. That's kind of what this episode is. There's no central theme here. It's just, well, me still on holidays, coming up with a bunch of little ideas, trying a few things out, coming across a few problems. It's it's kind of a mess. I do come up with one or two little gems that I don't really make use of, but wow, I'm delighted that I, have this video to kind of document them and carry them forward into the future because I might actually want to use something like this someday. But for now, it's just, put it on the back burner, back of the brain, because, yeah, well, at the end of this episode, I come up with one of the best ideas I've ever had concerning this project. And, well, it leads to part 19. So, yeah. Until then, you hungry? It's time for a dog's breakfast. Part 18. Let's watch. Looky here. New day. New attempt at something else. And this is real. 95%. Now, I'm running into a new problem. I'll tell you in a moment. How did I get 95%? Well, it's the color thing again. And it's only on how it's rendered back. Now here's the tricky part. I'm using the background color information, like the 1 byte, to flag whether it will either write the color to the screen uncompressed and quickly, like it's able to do normally and like it always has done, or if there's 10 or more chunks of 4 skippables, it will do it a little more carefully and yet take advantage of the savings to be had. Now, I think I didn't do a super accurate math check, but I think at around 10 chunks is when it starts to pay off. So my color flagger program now just will set the background color plus 128 in the cases where it has counted 10 or more chunks that got written back to the BBT. So it'll either be this or that, and either player will be able to play either one. I also relocated again the color at the end of the color, the last 24 bytes. I like having the background color as the 1001th byte, followed by the 3 bytes of the frame number, and then the rest, I don't know if they're gibberish or zeros or 128s or what. I could probably check in a hex editor. Anyway, my new problem. I didn't realize how close to dangerous I was, because as you can see, I've been making tweaks and running it and reassembling it and trying it again and again without a problem. But little did I know that I am now 55 bytes away from the variables that PAL keeps track of during assembly that work from the top of memory downwards to my object code going upwards. 55 bytes between them before one overwrites the other, and I'm going to have a collision. The other problem is my source code is now grown from 0800, of course, it's a basic file. It goes as high as 5FF something. Well, when I'm running my demos here, the audio buffer begins at 6400 hex. So I have 1 kilobyte left before my audio buffer would start overwriting my source code. And 1 kilobyte goes quickly, so I might have to rearrange things like lower the top of basic, change where my source or my object code is written. PAL will start a little differently, and oh, what a pain. But yeah, that's my new problem. What a pain. All right, it's August 3rd. Well, it just turned August 3rd. It's just after midnight. Now, I reinstated a very old debugging tweak. Every time the border changes, it's skipping a frame. Now, the problem I was having, I'm looking in the wrong areas to save, because if the color has chunks that you can just ignore, fine. But that might not be a good idea, because when it comes down to it, it's kind of like running a game. Not like I make games, but during the most hectic scenes is when your engine is taxed the most. So on the scenes where everything is basically not compression or skippable friendly, very busy frames, is the time that the what do you call it? The inefficiencies stick out. Now, instead of looking for ways to improve like the color, even though I could, but that would just put a patch like 93% becomes 95, but it's because it's better here and better here, but in the middle it hasn't a chance. How am I explaining this? Basically, what I hope to do, one of two things, is go over my code again. Oh, there's some glitching going on with colors there. Yeah, you see that? Now, that's, oh boy. I've been revising and resaving, and I gotta go look at that. Anyway, never mind that. One of two things. Go over my code and make it more efficient if that's possible, and it is. I was looking over it today. Instead of going into the generic routine, I can go in basically with the parameter set as how many times it does it once it's there and then leaves. Now, unfortunately, the sound filler routine needs to kind of go in one page at a time, or at least goes in, fills to 8,000, and then has to go fill from 6,400 to wherever the sound writer currently is at, because it chases the playing pointer, because it can't just fill a brand new buffer. It sort of chases the player. But as you can see, my skipped frames were very spaced out. And there's my usual 93, right? Yeah, these don't matter. I forget what I did wrong, but yeah. Man, I made a mess of things. Found it. This is the color writing routine. I kept switching it from sequentially to, jumps like this. Yeah, oops. Starts at 15. It's supposed to be that. That's why every 16th, when it hits 0, it just fell through. It's supposed to go back and do it for zeros as well. So it was skipping every 16th color wasn't getting written. That actually should have bought me some extra time, but hey, it didn't. I think there was two things I was supposed to tell you. The first one was look for more efficient ways to write my code. The second one might have something to do with this. This is my counting program again, examining the frames for solid, repeated chunks. And as already discussed, one's with 0 throughout the cell, and the other one is 85, which is the 010101 bit pairs. Those solid blocks are the most common. However, and here's where it gets bad. Try as you might to look for an efficient way to skip them, or whatever. Not too many cells, like 15 out of 1,000, use them. Oh, and frame 54, you only have 12. None of them are blank. Now, the completely blank cells are all background. Yeah, so what I was looking at the beginning and getting all anxious because the beginning is all black, right? So there's a lot of solid chunks, obviously. But later in the video, it gets busy, and then I guess the scene changed. I bet you those are the top and the bottom during that fantasy sequence. Who knows? I don't know, actually. But The old numbers that 211 and 227 can still be put to play, perhaps, and that is the payoff, or the price is corrupting my video in the slightest way. But I can notice every 2 seconds there is a skipped frame. It sticks out like a sore thumb now because I can see it. But if I can make a small sacrifice on the video output, perhaps I can squeeze a bit more something out of every frame. I don't know if that's possible. That's why I'm watching this, to see, where the repeats really are. And it's not looking too promising because these are very busy frames. Yet another thing here. I was thinking of this earlier today, so I already had this code pretty much written. If you examine the first cell of each bitmap on the fly, you have to compare it to 211 or 227, whatever you want to use. And that takes 4 cycles. But, and here's the big but, this is the amount of time that it's a low or a high, the high bit is set or not. So you could read the first byte of a cell and BMI if the 7th bit is set, and then do a deeper compare for 211 or 227. That way, anything like 60 whatever percent of it is going to fall through immediately on a 2-cycle delay versus a direct full-blown compare that cost 4 cycles all around. But on the 30-some% that do the BMI and then has to compare against the 211 is going to be 3 cycles more. And then if it fails the comparison and isn't a 211, it's got to spend 3 cycles to get back. So a fail, something with like say the number 175, is going to cost not 4 cycles. It'll cost 1, 2, 3, 4, 5, 6, 7, 8. If it's not, in fact, what it, if it's not a 211 or 227. Now it's not sounding so promising, is it? This might be a waste of time. What is this? Oh, what a mess. Wow, though. Just for fun, I thought, am I onto something? Actually, I'm not. Well, take a look. I'll just back it up here. So no matter what path you take, the overall weight in my sample frame is going to take 4 cycles in every case. Isn't that interesting, eh? Well, at first I thought, well, no, this was what I told you before. BMI, takeoff, blah, 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 right? But if it's not, it falls through. Well, it'll fall through for all of the low things, but the high ones, it has to go 3, 4, 5, 6, 7, 8 if it's not. And 34% of the time, it'll do that. Yeah. And the alternative, of course, is simply this right here. Load, compare, branch. And if it's not the rare, it'll fall through. And it's always a 4-cycle price. So no matter what, this routine will get paid 4 cycles for that compare, however you slice it. But wow, looking at it like this, it's just, I did not think that this would be the case. Interesting stuff, eh? All right, it's almost 2 a.m. I'm going to pack it in. But, yeah, check this out. 211 hex, if I use that as a flag, for example, when you see 211, skip the entire thing. But if it's really 211, like I said, that's going to be a corrupted cell. Not necessarily, because this is a 211. But what if you just swap 2 bits in it to make it a nice 199? Only 2 pixels of the cell are now corrupted, and the other 7 are just going to render as normal because this is not a packed byte. So if it sees a 211, it automatically can happily, without a doubt, skip that cell completely. But the color RAM and the video matrix need to be set to whatever the 00s are. That'll take care of the 00 problem. If this is all 85s, that isn't going to fly. Here's a trick. If it sees 211, it can grab the second byte. If it's 0, take off, because the color RAM and the video matrix will be adjusted to compensate by a different program. But if it's 85, then you have to do the repeated printing. Now that you have the value, you have to stuff them all down. But that means 8 self-modifying code writes for every of the 31 pages of the bitmap. Or you can just go, screw it, this is only for zeros only. 85 can go, whatever, take care of itself. I don't know what I'm going to do, but I ain't doing it tonight. A new day, well, a new evening actually, in between rounds of Fall Guys here. Yeah, it's a good thing I have a super CPU. I mean, besides the fact that it's freaking valuable if I ever choose to sell it. It comes in handy for stuff like this. I am now adding up the occurrences of the rare frames as a group because, yeah, well, let's see what the overall savings can be with the zeros. But there's always catches. If there's a huge amount of savings in certain frames and almost no savings there, well, it don't matter. If it's a huge amount, it's not going to carry over. After a certain threshold, any additional savings isn't going to help because it's still waiting on the time for the next frame. So it's kind of like if you can render a frame way faster than necessary, well, the rest of it is wasted time. I only need to save a small amount on every frame to get to 100%, which isn't going to be the case because there's some busy frames here, and yeah, but let's just see what the overall is. I'm curious because, well, that's pretty much why I do everything, because you're curious, right? Like, this entire project is complete waste of time. You don't need to do anything, but what's the point of life, eh? Another idea here. I can take the 85s. If it sees 211, it knows that that is a 85 repeated. What about the zeros, you say? I can pre-render those as 85s because there's no reason that anything needs to be a complete cell of the background color. If it's going to be a complete cell of a single color, I can make it any color I want using any of the bit patterns I want. So make it 85. And stuff the color to be into the video matrix low nibble, and there you go. Problem solved. It'll end up dealing with repeated things, so it'll still have to render them, and it won't be able to skip stuff, but it'll handle the zeros and the 85s together in one shot. Neat. And here's the totals. The value and the number of times. It is a solid cell of that value in the entire video. Now, duh, it's obvious that these were the only 2 that mattered, and they still are. Together, what is that? About 73,000 cells. There's only 1,000 cells in the entire screen. So 73 out of 900 and some complete frames in total are a solid chunk of not skippable color. Oh, the phone's going batty. Not skippable, but time reducible by doing like the check for 211. If so, go over here, load accumulator with 85, write, and then go back. And that's it. You don't have to load, you don't have to do further comparison, you don't have to check if the second byte is anything in particular. That's if you change the zeros to 85 and set the background color to the low value of the video matrix for that particular cell. it's not going to be as fast. Some frames aren't going to have as humongous of savings as possible, but like I already said, it's only getting past a certain threshold that's important. And I now, just like everything I've been doing, I think this is now the right course of action. So I will pursue it next and see where it leads me. Boy, oh boy, oh boy. Luckily, it won't be too hard to implement. The biggest pain is keeping track of which bitmap cells need to be changed in the video matrix. Boy, I don't have code set up for that yet. Yes, more numbers. Once again, number on the left is the value, number on the right is the number of times it appears first in every bitmap cell in the entire video. And on this particular screen, you get both. You get 211 and 227. Some of the values here, obviously 0 is important. You see this? It's like, no wonder like 211 and 227 are such good ones to pick as rare, because out of nearly 1 million cells, less than 20 are those values combined, which is great. But I wonder, because I mean, well, never mind. I have a way to deal with the color, and I'm going to show you that probably right now.